welcome. This is a presentation by Hewlett Packard Enterprise at DDN Theater. You would ask, why are we doing this? Well, that's because we recently announced a partnership between DDN and Hewlett Packard Enterprise. We're very excited about it. We've done a lot of business in the past. As SGI, you probably have heard that HPE has acquired Silicon Graphics International in 2016, and a lot of the relationship has transitioned over to Hewlett Packard Enterprise, and most recently we have actually solidified that with a partnership agreement between DDN and Hewlett Packard Enterprise. So I'm going to talk a little bit about our perspective, HPE perspective at data management in the new world of high-performance computing and AI and machine learning. And I also would like to touch a little bit upon how DDN fits into the overall scheme of things that we do at HPE. So with that, I'm going to skip a couple of slides here. We have spoken to a lot of our customers over the years about the problems that they are facing in high-performance computing and artificial intelligence. And obviously, one of the key issues with HPC in general is managing the cost. And storage is usually the one that gets the most hit because everybody wants to compute first, and then storage is kind of a distant second. But nonetheless, it's very important. Now, nonetheless, in this environment, we still see a significant increase in demand for high-performance I/O, particularly small I/O. So there's more and more small I/O. It's not just checkpoints and memory loads. It's also random, kind of a mixed workload that we have used to see in enterprise. So how do we solve that in a cost-efficient manner? That's one of the key problems. That's the question that users frequently ask. The second issue is scalability. We've seen skyrocketing number of objects across the across all our user community pretty much. I mean, everybody is dealing now. I mean, in genomics, in all kinds of verticals, we're seeing significant file counts. It's not unusual to have file systems with billions of files. We have regularly have customers that are telling us that they are exceeding 10 billions of objects. So at that rate, the file systems, traditional file system solutions, just no longer work, no longer applicable. So that's a big issue in the customer community. Then there's workflow acceleration. Now we're trying to bring systems together of different kind. We're bringing together HPC, high-performance computing, big data, artificial intelligence, machine learning, deep learning. How do we make sure that we share the data efficiently? That's a big challenge, because what the users really want, they don't want the fastest system necessarily or the fastest storage. What they want is they want to complete their workflows in a given period of time. The more workflows they complete, the better off they are. I mean, this is essentially what they're looking for. And finally, last but not least, is data assurance, most certainly. With multi-petabyte, I would say dozens of petabytes, and being regular size in the data environments, we're now definitely exposed for all kinds of bit flips in the storage, in fabrics and networking everywhere, and that's a big deal that we're looking to address. So with that in mind, if you look at the technology shifts, I mean, this is a kind of a very simplified picture of your HPC system. You have a compute cluster on the top, and then you have some kind of a high-performance storage, and traditionally this would be a Lustre or GPFS, and then you have capacity storage, and that would be your archive, potentially tape, or object store. What we're seeing that is happening in the community is that the high-performance storage tier becomes integrated with the compute. More and more, I mean, it's solid state, so it's natural for the solid state storage to get closer to the processing element, to the compute, to the CPU. So we essentially wind up with two tiers. One is integrated with compute, and the other one is a capacity storage that is essentially a storage backend. And it's important to be able to scale them independently, in such a way that you right-size the high-performance tier for the workload that you need, and then the rest is basically in capacity storage. That allows you to manage the cost between high-performance, probably expensive tier, and lower cost by high capacity and highly scalable tier. In order to get this done right, we need to have some sort of a data management solution that ensures that the data is flowing at the right time in the right place behind the scenes. So such solution is HPE Data Management Framework that meets the need that I just described, and it's essentially a all software layer that works with both the high performance hardware that is located in the compute and the capacity storage that is outside, and navigates this complex landscape. So what does it do, and how does it kind of fit into overall technology landscape? Well, first of all, we're seeing transition between, actually transition away from huge, enormous file systems that host many, many objects and require traditional backup in order to preserve the data, or copying the data outside of the file system, or snapshots or something like that. With the number of objects that I mentioned earlier, it just becomes impossible. And this is where we're seeing transition to more of a dynamic, ephemeral namespaces, which actually are created by the data management systems on demand. As the workflow requires to process a certain stage, the namespace is created and the data is staged there and run. The job, the HPC job or AI job gets run, and then the results of that get destaged, and then the data gets captured by the data management system. The provenance is tracked, and then the data is protected according to the policy. Basically, how many copies you want to create is that 2 copies, 1 on tape, maybe 1 in object store, 1 in high performance storage, and so on. So, to bring this all kind of in a context of actual hardware, we have the compute cluster on the top. We have high performance storage, and that could be traditional lustre GPFS parallel file system, but also increasingly all flash on demand scalable file systems. And then you have the HP Data Management Framework that I just mentioned, and that's where that's what keeps track of metadata, data provenance, and also performs policy-based migration based on the requirement of the job scheduler. It also takes care of the protection on the back end. Basically, it repairs the data that needs to be either healed or perform disaster recovery. The back end typically is represented by either object storage, S3 connectable storage, or high latency media such as tape. We also have some interesting technology called 0-watt storage that is kind of unique. It's essentially a JBOD that is used as a bunch of tape cartridges. I mean, you can think of disk essentially as a tape cartridge where we can stream the data with a very high speed in and out. So, how does DDN fit here? We have been working for many years, as I mentioned before, with DDN. We have many successful customers that we continue to actively deploy. So in addition to our own offerings for example, for Lustre, we definitely work with DDN Exascaler, and we work with Gridscaler for GPFS. We also are offering IME, DDN IME Infinite Memory Engine that provides the necessary acceleration in this high performance, ultra high performance tier. We work also with other leading technologies in this area, but the DMF, Data Management Framework itself, is actually fully facilitated by the HPE team. So the HPE has embraced the DMF. It came originally from the SGI acquisition, and HPE continues to heavily invest in that technology. And then on the back end, of course, we have our own tape libraries. We have Ceph and Scality, and most importantly, DDN WAS, which is also an object store that we can connect to and work with. So fundamentally, we offer different choices. We offer HPE-based technologies, but we also offer DDN-based technologies, as I mentioned, Exascaler and Gridscaler. Just to mention a couple more things, so about DMF. DMF has been around for a long time, and we have deployments with DDN arrays, but fundamentally, it's been around for over 25 years protecting the data. The key aspect of DMF that sets it apart from other archiving systems is transparency. We actually see all the files that are archived inside the file system directory, so you don't have to issue special commands in order to pull archive or list archive or anything like that. All the files are available at any time, and they can be pulled in just simply by access. We also, of course, provide all the data management, archiving, integrated backup, validation, and repair within this framework. And it's completely policy-driven, based on file attributes, based on directories and things like that. An example of a deployment would be at a space agency that all of you know. That's what they are using to keep their data for over 20 years. They're growing at actually 6 petabytes per second. I'm sorry, 6 petabytes per month. I was a little too fast there. And they have a requirement to retain the data for 50 years, because that is the kind of data that they get from space. If it's lost, you can never recover that. Currently, they are at 150 petabytes under management, but they can scale all the way to half an exabyte based on the current deployment. Very nice, good headroom, so they're in good hands over there. And again, one other aspect about the DMF that I'd like to manage is that it enables future technology integration. So, for example, this is a typical deployment scenario where we have policy-based management and a number of backends. And then, for example, a new technology comes across, and that migration occurs completely seamlessly, even as the users continue to access their files, even as they continue to do their work. And it can take months or weeks to migrate from one technology to another, especially tape. We're migrating now to LTO 8 that just came out. And that process is very long, but the important thing is that the users don't even notice. Essentially, we're building hardware around the data versus putting the data around the hardware. Similarly, with all flash file systems, burst buffers or IME technology, we can stage directly into that and also leverage DMF for that type of activity. So with that, I just want to show one last slide, and that is essentially our data tiering model. We believe going forward that we will essentially continue to, in HPC environment, we will continue with POSIX namespaces because the applications demand it, and they will continue to use that. But we'd like to bring the data into this high-performance tier, which we like to call tier 0. Essentially, that's as close as you can get to the CPU. It's the NVMe or SSD storage that is attached directly to the CPU. That's what provides highest random I/O performance, but it only serves partial namespace. It doesn't serve the entire namespace that may be available within the archive or within the backend stored below. There may or may not be data redundancy. Again, we're trying to save cost. We're trying to right-size the high-performance tier for the workflow or the workload that we're looking to address. And that's where we support POSIX. The backend store, we do not support POSIX there. There's no need. Essentially, we use that for the dormant data form. We send the data, migrate the data out of the tier 0 when we're done with it, and it needs to be preserved for a long period of time. And there, we essentially only need good streaming performance, good scalability, very large namespace. I'm talking about possibly over 10 billion. So the design point for us is about 1 trillion different objects, and we need strong data protection such as erasure codes. That will, departing from POSIX at that layer allows us to do interesting things, like, for example, provide multi-site support, perform geographical replication, perform backup without doing backup, because all we need to do is define the policy for migrating the data at the right time. Like, for example, we can do the policy, migrate everything that has not been migrated yet, and that allows us to essentially run equivalent of the backup without any interference with the user. And that, of course, provides cloud integration. With that, I'd like to see if there are any questions from the audience. Anything that I mentioned?
Any questions out there?